Welcome back from lunch. We're going to move on to our third talk now, which will be given by Rani Lill Anjum. Sorry if I pronounced that terribly. Unfortunately, she can't be with us, but as you can see, she's online, and we'll be talking about philosophical tensions between evidence-based and person-centered practice. Off you go.
Yeah, well, thank you very much for inviting me and for giving me the opportunity to do this from Norway. So normally these days or these years, I've been talking mostly to non-philosophers about these things. So I'm not sure if everyone here is a trained philosopher, but if you are, then I'm sorry, because I will try to keep the focus so that people could follow if they don't have a background in philosophy. So I want to talk about a topic that I very often discuss with people from the health sciences and clinicians. And this is about how philosophy influences different sciences and practices and scientific methods. So together with Fredrik Andersen and Elena Rocca, we wrote this paper where we were very happy to use the term philosophical bias in science, where we explain how there are some biases that you cannot get rid of, and you also shouldn't try to get rid of them, but you should be aware of the disciplinary biases that you get from your education that are philosophical in nature. And so what we say is that very often you have tensions, scientific controversies, or disagreements between experts where it's not primarily a factual disagreement. It's not like they disagree over the data. It's more about which data count as interesting results, what types of results do they amount to, which methods should you trust, and how would you, for instance, estimate things like harm, but also like benefits and causality, probability. So there we say that one cannot avoid to have some philosophical bias that one has adopted through usually the education. So philosophical bias is also an acronym for basic implicit assumptions in science of a philosophical type. And I will explain this more thoroughly. So it builds on work that I did with Stephen Mumford. I worked with him for many years. And one book that we wrote was about how norms of science are often motivated by philosophical assumptions about causality. And many of the norms that we accept and that we can see in the broad scientific methodology comes from empiricism. So this is something we argue here. But since then, I've been working primarily in the health sciences. So that's what I will focus on here, which is also the topic of this workshop. So the evidence-based framework, I would say, in a way, it was maybe primarily a philosophical revolution because there was a change in ontological understanding, how we understand reality. And reality here could mean things like what is causality, what is probability, what is risk, etc. But it was also an epistemic revolution where one changed very clearly how one understood scientific knowledge and the norms for what counts as the best scientific practice. And that's why I have the little pyramid at the top here, because when the evidence-based framework was introduced, the evidence hierarchy was very clear with randomized controlled trials at the top. And then it has become a bit more blurred lately. But I would say that maybe this blurring has been a way to try to have your cake and eat it, to have it both ways. Because there has been some criticism against the evidence-based framework that the person-centered or person-oriented practice is a bit difficult. And then usually what is happening now is that one tries to say that one should be both evidence-based and person-centered if you're a clinician. But I would say that if we want to switch to a genuine person-oriented framework from this type of evidence-based framework that we had, it should also be a revolution. Because we have a new way of understanding reality, new understanding of scientific knowledge, and new norms for best practice, which I think are in tension between these two frameworks. So the clinician is usually the one that is in the squeeze, because if you do the research, but you don't have to really apply it, it's not a problem. But of course, anyone who has to apply the research to make advice, they will be in some kind of squeeze if they ever have to deal with the person. So the clinical squeeze, I would say, is between the unique individual that should benefit from the decisions and the population from which the evidence is often derived. So the evidence-based framework has a focus on the population. It talks about equal treatment for all. So everyone should get like the best treatment that is based on empirical evidence to work best. Very often it's statistical approaches that has been the focus. And the idea is to standardize treatment and apply or develop and apply clinical guidelines. So the guidelines, they should be applied broadly unless you have good reasons not to apply them. So very often then one would assume that the patient in front of you could benefit from evidence from the same type of patients, the same type of population. The type of outcome that we often get from this type of population research is things like numbers needed to treat, numbers needed to harm. And this is different from the person-centered framework where you have to take the guidelines or take the evidence and apply it to the unique individual in front of you. So this is what happened when I was starting to work on this causality, complexity, and evidence in health sciences, was that people said that, well, we know that all patients are different. So it's not like they are ever the same. So in the clinic, one would be most concerned with what is the best treatment for you. And then you have to think what's the relevant knowledge that you can use. You will have a lot of evidence, but there will be other knowledge as well. And you might want to be person-oriented. You want to think of this unique individual and adapt the treatment to them. And then you have to think of what is the local context. What's the contextual considerations that are relevant here in this specific context? And you have to use some kind of judgment. And the judgment is something that the evidence-based framework also was a reaction to, that everyone was using their own judgment and their own favorite treatment. And this was not how it was supposed to be, because the evidence could show that this treatment is not the best. There are other treatments that are much better. So that's also why this judgment part now in the evidence-based framework has to be a bit downplayed because of the motivation for introducing it. So here in the reason to focus on the person-centered approach is that one has these individual variations and sometimes uniqueness. And then you know that one size does not fit all. So the philosophical biases in health sciences, I want to start by saying something about what kind of philosophical framework that would make the first framework, the evidence-based framework, the absolutely best practice that we should use on all our patients. So I start with the idea of empiricism, because it's a very empiricist-informed framework. And I'm sorry to the philosophers who obviously know what empiricism is. But the point about empiricism is that knowledge should come only from empirical facts, so we should use observation. And one thing that follows from this criteria of knowledge is that theoretical speculations about that try to explain the data would have to be to some degree speculative, because they go beyond the facts. So the data themselves, they don't really tell you why they happen the way they did. And also predictions, they usually rely to some degree on theory, or at least generalization of the data. But those will be problematic because you haven't observed the future. So you never know if your prediction would be true. So I would say that David Hume's theory and concept of causality has been allowed to set the premises for most scientific methodology, and especially what we see in the evidence-based framework. He talked about causality as regularity and correlation, and this has to do with what we can observe. So we can observe that you have a regularity of events, you have some repetition, and if you don't have repetition, then you would never be able to claim that you have a causal case. So, and that's because, I mean, you cannot observe the causal relation outside the data. So the causal model is a bit like his billiard ball table. You have something happening with one billiard ball, something happen with the other billiard ball, but the question is whether there is a causal relationship between their movements. So the question here is always like, okay, what does it take to go from observation of correlations and repetitions to say that actually here we have a causal relationship? And this problem we have inherited from Hume. So this is the challenge of the scientific method. And then the question is, of course, what do you take this causal link to be? So what do you want to fill in here in the gap in your scientific method? So the different, so we heard already about causal pluralism, that there are many concepts of causality and not all of them are the same or point in the same direction. So one might think that the more different types of methods you have, the closer you get to some kind of causal insights. The problem is that if you use different methodologies and one method says this is causality and the other method says it isn't causality, then you have to have some criteria for saying that you trust one method more than the other. Otherwise, you won't be able to choose. Or you could say that, well, I'm a pluralist in the way that as long as at least one method says that this is causality, I'm going to say we have causality. So that could be another option. But one idea, at least, is that you have pure regularities. So all you really need to see is that you have both the cause and the effect regularly happening. So if so, this is Hume's one of Hume's concepts, and if you believe in that, then of course you should need quantitative approaches, maybe observation studies. The bigger the data set, the better. You can use statistical tools to analyze these correlations in various ways. So anyways, you would start with some correlation data. So that would be your preferred scientific methodology, for instance. Hume also introduced the counterfactual dependence idea, saying that a causal relation also means that if it hadn't been for the cause, you shouldn't have the effect, which means that a cause becomes a necessary condition for the effect. So then you would want to check, well, if you don't have the cause, would you still have the effect? So you would have to kind of like minimize some kind of complexity, maybe isolate the cause from contextual factors. Maybe you have to make some idealized settings because, for instance, if we're looking for a gene and a trait, it's not easy to isolate the gene. So you would have to make some lab models, for instance. So, but the important thing is that you will have to compare when you have A and when you don't have A, and see whether you get B, which you assume to be the effect. So people who are critical of the pure regularity theory, they sometimes want something else to be there in addition, which maybe gives you kind of maybe ontological truth maker. Maybe there should be something in the world that makes this true. So for instance, that could be a law of nature. So Hume wouldn't like that, of course, because you cannot see these laws of nature unless the laws of nature are just stating all the regularities. But here, I would think there are different types of laws. Some of them would require abstraction. But the important thing about the law-like connection is that you should have this perfect regularity under some same or ideal context. So you need to in some sense at least, idealize and abstract and make some models. Maybe it has the form of an experiment, but the idea is that you should try to come up at least with some criteria where you could in principle have perfect replication, or the whole nomological machinery that Nancy Cartwright talks about. She says this lab that creates these perfect regularities is a law-making machinery. So a difference maker could be thought of in different ways. But one idea is, of course, that the cause should make a difference to the effect on a statistical level. That could be one way to think of the difference maker. The other is maybe a difference maker is that the effect happens in a different way, or maybe later, maybe sooner. So that's a bit vaguer, or maybe it makes a difference in the sense that you didn't get it and now you get it, or vice versa. But also here, to study the difference, you need comparative studies. So maybe experiments with controlled, I would say randomized controlled trials, they are perfect for looking at statistical difference makers. But also N01 studies is when you give the same type of the same person different types of treatments and compare. Here's the interventionist theory that says that you need some idea of manipulability or intervention, where if you change something in the cause, you can also change something in the effect. So that would suggest there is a link between them, and this is a good concept for thinking that you need the experimental method, for instance. So also here you might need to have some comparatives, some control, maybe lab context. So it depends on what type of intervention you want. And then you could say, okay, all I need is really a probability raiser. So I want to see that when you have the cause, that you raise the probability of the effect. And then quantitative methods, observation studies, large data set, you need to compare them to see whether you have a higher probability of getting the effect when you have the cause than when you don't have the cause. And then it's the question of mechanism that we talk a lot about among ourselves here in these causality in medicine networks, but it's not clear that everyone means the same by a mechanism, because the mechanism could be something that is just between A and B, and that would explain why you have a perfect regularity or a probability raiser. Or it could be something like Donald Gillies talks about, that it is much bigger, and that is like complex and maybe an open system where you can always develop your mechanistic understanding, and then it's a bit more like a larger theoretical idea. So depending on how you understand it, then maybe quantitative methods could be enough, maybe seeing many repetitions, zooming in on regularities, maybe that could be enough, or maybe you would want to have also more qualitative approaches, for instance. So you see here. It depends. Very often people learn about causal graphs, but I would say with the causal graphs, you get exactly the same question as you get when you only have the 2 billiard ball, like what does this arrow mean and what do you need to talk about a causal link between them. So with from this empiricist perspective, which I would say many of these, when you start with those cause and effect that are observable and you look for an unobservable link, I would say that it's very motivated by the empiricism, at least the empiricist's premise about what causality is, correlation plus some invisible link between them. So you start by looking for this regularity and then you ask, should there be something more? But at least the best scientific method is to search for correlations from as many repetitions as possible. And then to have big data sets is always very good. But then also one thing we should be aware of is that the causal question almost becomes translated into a quantitative question, which is how often does B follow from A? Does it follow B? Does B follow often enough to say this is causal link? And then causal evidence seems to be very quickly related to statistical evidence. And I think this is what happens when we focus a lot on randomized controlled trials as the only causal evidence that matters, is that we want to see these numbers. And very often they come as probability estimates. So it's a kind of probability racer, difference making thing. And the stronger the correlation, the better causal evidence, one could think. So if we can sum up this, the focus, I would say, on these approaches, almost whether you take one causal concept or the other, I would say it's this focus on the same cause, same effect under maybe the same conditions or under ideal conditions, that you look for some difference maker either in the single case or statistical difference maker. I mean, the single case, that wouldn't be easy, but the N01 would be one place where you do that, except you will still have to make repetitions. And maybe you can find a necessary condition, whether or not that amounts to causality, that depends on the theory. But to find a necessary condition and difference makers, very often you have to kind of separate and isolate different causal factors. But the idea is that you look at empirical data, and the monocausal model is like the ultimate causal idea. So if we look at probability, for instance, from this perspective, you could get also an empiricist probability idea, which is based on observation, correlation data, statistical, mathematical, based on populations, without theories and without causal mechanisms. And that's the frequentism. And frequentism, you know, you need lots of data. You don't want to have a lot of theory. You always get a precise estimate, and risk becomes a number. So for instance, number needed to treat, numbers needed to harm. So I want to now look at a more person-centered framework that we have proposed in our research. So it starts from the dispositionalist perspective that challenges empiricism and says that we need to understand causal potential and capacities and intrinsic properties. So we call these causal powers dispositions. It could be things that haven't happened yet, so it's not yet observable. So knowledge about such potentials will have to go beyond what is observable. So looking at the causal powers and dispositions, I would try to say a bit about how this could give you a motivation to think about the unique patient. So we wrote this at the end of the project. We wrote this book, Rethinking Causality, Complexity and Evidence for the Unique Patient. And we were 3 philosophers, 8 clinicians, and 1 patient. And we tried to explain how starting from a different philosophical framework could give you a more centered, person-centered focus. And that would also mean that the way you look at causal evidence would have to be, I mean, you have to use the causal evidence and understand the causal evidence a bit differently. So we have had a lot of chapter downloads since it was published. Let's see, here are the people who wrote it. We start with the philosophical framework, and then in the second part, the different clinicians and the patient advocate translate it into the clinical setting. So one basic idea is that we need theory. We need to understand theories of mechanisms. We need to understand potentials. We cannot only rely on data. So in this framework, causes are linked to dispositional properties and effects to their manifestation. And any kind of causal causality would happen through interactions. So for instance, you can have something that is explosive, but it hasn't exploded yet. And you might say that when it explodes, causality has happened. But it's not necessarily the case that you want to test many times that it explodes, but you want to understand what might potentially happen. And so here, causal evidence cannot primarily be about correlations and difference makers, but it would have to point to some type of mechanism and intrinsic properties, the interactions of these properties, and what we call mutual manifestation partners. So for instance, you put a pill on the table, it does nothing. You have to give it to a person who is a receptor that maybe has the biological receptors needed to get the advantages, the benefits of the drug. So here, the causal question we think should be how and why, or under which conditions would A produce B. So B shouldn't just follow from A, but A should somehow produce or partially be part of producing B. So of course, this is a controversy that is never going to be settled between philosophers. So the empiricists, they say, okay, dispositions, you cannot observe them, only the manifestations. So dispositions are a mystery. Why should we care? And dispositionalists would say, well, how would you explain manifestations if not by dispositions and interaction? I mean, if the glass break, then surely it was fragile. So if not, manifestations are a mystery. So, I mean, this is for us philosophers to argue over. Here, I just want to show the difference, like in the methodology. If we want to explore causality, then does the heater work to warm up the room, for instance, to 25 degrees? The empiricist is going to check this by turning it on and checking the temperature. And then you can repeat it, you can randomize, and then you have to check how often is the temperature as expected. So for instance, 25 degrees. And here the idea is that you focus on the expected outcome and the repetition. So you want to have as similar as possible setups. For the dispositions, it doesn't work in exactly the same way because you would be interested in maybe variations as well and look at which local factors that affect the temperature. So for instance, when you have contextual interactions, it's different between like a standard normal ideal context and context where you don't really need the intervention, or context where the intervention is not going to really do any work. But again, how to think about this will depend on theoretical understanding. So if we take Hume's causal model and apply it to dispositions, which I think many dispositionalists would do, the idea is that you have the disposition, for instance, the fragile glass, and then you have the cause, which would be the stimuli, which would be to, for instance, smash it, and then it breaks, which is the effect. So the suitable scientific approach here would be, of course, to have like a mix of methods, maybe qualitative approaches, but we would want the complexity to be part of the causal model, and also to show in the causal model that the actual temperature in the room, the effect, the observable effect, might not happen just because you have a causal relationship that could produce the effect under certain conditions. So here, yeah, you can have the heater. It would be good enough to heat up the room maybe to 30 degrees, but you have counteracting factors, for instance, an open window, or like the terrible room without walls. So there are various things that could contribute and interfere. So the combined result might not actually be something that would count as a result. But then to go from there to say if the heater doesn't work would not be correct. So the suitable scientific approach here, I would say it's a mix of methods, but definitely qualitative approaches. And you need to have theoretical knowledge, you need local knowledge, and you need to understand context. And you also need to understand interactions and interference. So this is what we would maybe say is the mechanism. So one thing that we have talked about in our research when it comes to dispositions and causal knowledge is that you need to have qualitatively rich causal knowledge about the intrinsic properties and the local context. And this is because the context sensitivity, that it matters what is the context that the intervention should work within. That's really important. So you need to understand that. And then if we don't have access to this knowledge from before, then when things don't work, when you don't get the expected outcome that you would have thought that you would get, then one should go in and study that context in detail. So we say a lot can be learned from studying these contexts of causal failure and marginal cases. So for instance, for drug safety and pharmacovigilance, you can learn a lot about how the drug's mechanisms work that were not maybe part of your previous knowledge from looking at side effects, and sometimes very rare side effects. So, and also when we think about risk evaluation, for instance, they need to understand complexity and interaction. So for instance, cumulative risk is really important when it comes to health effects, but the scientific methodology makes it really hard to study complexity. So very often risk assessment methodologies, they separate and isolate one by one, and then they add up the results to find out what is the overall type of risk. So when we look at causality from a dispositions perspective, then one should have focus on variations and uniqueness and sensitivity of context. And one should look not only at A and B, but all the other factors in the context that could contribute or counteract the effect, and to think about complexity as a default of causal production, and also think about maybe non-linearity of interaction. So here you need to understand causal mechanisms, so you need to develop your theory, which is never a finished thing. And you need to have more multi-causality. So here's an idea of dispositions and probability that is called propensity theory. So it's based on the idea that you have different dispositions and potentials. And here you can see in the illustration that it's about looking at the local properties involved and not how often someone has fallen into the pit, for instance, or what happened to them, or how likely it is that they will fall, or how likely it is that they will jump and fall and hurt themselves. So this is not about giving a numeric value to your expectations about whether they fall in, or to count how often. So this is a locally oriented idea of single propensities, and it's founded on theory, and it's founded on causal mechanisms, and you cannot generate these propensities statistically. But then also, when you look at risk from this perspective, it's really hard to give a precise number. So it's like if the decision makers, or if the methodology or the people who look at the methodology require that risk and probabilities is something that should be given a precise numbers, then this theory has already lost. So here you have lots of mechanisms. You have very little data. You need theory to explain. You might want to reason in a precautionary manner because it's about potentials and not what has actually happened. And you don't need so much mathematics and statistics to talk about this. So, but then you don't get the number. So the clinical squeeze is that they want both. Not the clinicians necessarily, but this is what is expected of the clinician, to be both evidence-based and person-centered. So how would the clinician combine these two frameworks? Because the evidence will look at same cause, same effect under the same conditions, and maybe statistical difference makers, maybe some necessary conditions, maybe you have isolated causal factors, and your patient has maybe comorbidities, multimorbidities, that is more often than having just, it's more common than having just one issue. You have all these different people. One of our clinicians, Roger Carey, said he was asked to pick out patients for a randomized control trial, and all of his patients were excluded. They didn't meet the inclusion criteria. So then he started thinking, why should I use this evidence on my very different patients? So when you have this type of tension here, I think it's really hard for the clinicians to be both. I mean, it's like, it's easier if you just buy into the empiricist framework. So one thing that we have tried to argue is that the clinician is the one who meets and talks to the patient, and that knowledge about the unique patient and their context is causal evidence. And this is why the clinical evidence should inform also medical research, which in drug safety, in pharmacovigilance, this is also how it works. But very often, one ends up with statistical approaches where you count how often a certain side effect is reported. So there's still this tension. So here is, we got our own meme where someone tried to summarize the cause health book for sports science. So here you see, if you're evidence-based population average athlete, then you're fine in sports science. But if you are a unique athlete with unique dispositions, then you're not so fine. And then one person says, probably this theme plays out in all of medicine and healthcare. So I think I will end there. Thank you. I don't hear you if I'm supposed to hear anything, but.
Okay, there we go. Can you hear me now?
Okay, yeah, now I can hear.
Thanks so much, Rani. Very cool to end on a meme, all about your own work. So questions, there's one here. Let me run up and give you a mic.
Is that John?
Thank you, Rani. That's really interesting talk. I really like the idea of philosophical bias. I think that's a really nice idea. I was just wondering, I'm not sure why you don't think we should get rid of philosophical bias, because it sounds as if philosophical bias is pernicious, at least in the causality realm, because it steers us towards one particular method and it leaves us liable to exclude others. And this is dangerous in science to exclude valuable sources of evidence. And so it seems as if there's a strong case for saying we shouldn't adopt a metaphysical theory of causation if it's going to prejudge some of these contentious questions that haven't been settled about the epistemology of causation. So I don't know why you don't want to get rid of philosophical bias. Maybe you could explain that.
Yeah, thank you. Yeah, the philosophical bias, I mean, if you say that we should avoid ontology, that's also like a philosophical assumption. And if you say, well, you're a pluralist about causality, that's of course also philosophical bias. So what we're saying is that you could want to get rid of philosophical biases in science, but you cannot, because you cannot assume nothing at all about what is the nature of causality or what could be the nature of causality. I mean, if you assume absolutely nothing, you wouldn't be able to find the scientific theory. Like you wouldn't find a method for looking for causality, so you would never have any methods to discuss. So what we would say instead is that, and this is what we do now because we have a course on philosophical bias in science here at the NMBU, which is now mandatory for all the master students in environmental sciences at our university. And what we say is that it's really important to be able to recognize and identify philosophical biases in one's own education via, for instance, methodology or theory or best practice, and to be aware of what are the philosophical framework that would back up this, and what are the alternative theories, and what are the strengths and weaknesses of each of these, and then you can make like a considerate choice. So for instance, we can explain people about how some type of methodologies are maybe reductionist, and then we could discuss whether such reductionism, like what are the arguments against it, what are the arguments for it, and what are the alternatives, and then what type of methodologies would you need if you wanted an anti-reductionist methodology, for instance. And then it's really interesting to hear what students have to say about how the different teachers say completely different things to them, because they have teachers from different disciplines. And even within the same discipline, they would favor different approaches. So it's more about talking about how we have to be aware that there is this foundational assumptions when we talk about probability, risk, complexity. So we talk about process ontology and thing ontology, for instance, because that influences methodology quite a lot. So yeah, I would say that you also would bring in philosophical biases by saying that we shouldn't assume anything, but still accept the methodologies as maybe useful methods for picking out causality.
Did you have a follow-up, John? Or no. Okay. There's a question from someone in the Zoom, Tushar. I don't know if you want to unmute yourself.
Yeah. Hi. Thanks for the presentation. Am I audible?
Yes, but I can't see you. But
yeah. So my camera is not working.
Okay.
I'm sorry. So my question is somewhat related to John's question. So it's not that we are not assuming something ontological or metaphysical within some conception of causality, but within at least naturalized picture of sciences, we would like to subscribe to how a particular context looks at the notion of the cause itself, rather than imposing a universal or global conception of cause overall. So if that's the case, okay, because and my worry is also informed by Longino's case studies on human behavior, where she studies what she calls causal parsing in different contexts, and where people have taken multiple causal factors within one context. They haven't really been able to produce empirically useful results. For example, in system-based approaches in studying human behavior. So first question is that why shouldn't we take a more naturalistic attitude towards conceptualization of cause? And second, if we take multi-causal picture of context, how is it going to be empirically relevant and give us fruitful direction in devising certain methods, approaches, or intervention or actions?
Well, that's not an easy question, because I'm assuming that there are a lot of philosophical biases there as well. But yeah, okay. So empirically useful. So, for instance, with the way that we have discussed causality in medicine and pharmacovigilance, one thing that we have said is that you need different methods to find a disposition, for instance, to find something that actually causes something else. So I work with Elena Rocca, who is a pharmacist and researcher of molecular biology, and she says for her, in the lab, it was always quantitative approaches and counting and looking at what happens in the lab as the actual results. But she also said that there was a philosophical bias at the time, not only of reductionism, but also that you needed a story, a theoretical story, to explain why you got the results that you got and what is actually happening here. Otherwise, you wouldn't be able to publish your results. So she said the idea was that there was something intrinsically going on here that you needed to like add to your results. But she says now there has been a change also in these natural sciences, where maybe it's more acceptable to just publish the data and to publish them as maybe not making a causal claim, but just indicating a direction. So what counts, or what is seen as being empirically useful knowledge is also something that doesn't really, it's not something that is just settled. It's also like in public health, for instance, it's very different camps. The people who believe that we should stick to the data and not try to speculate about causal claims, and those who believe that if we don't say anything about causality, then the data are not very interesting. So, I mean, this is what we're trying to say, that, okay, you can take our approach or not, it doesn't matter, but whatever approach you take, there are some assumptions that you bring with you of a philosophical nature about what is this type of thing. And then it is useful to know about the philosophical debate on these things so that one can make an informed choice and to have actually be part of this discussion in your field. Because I think a lot of the scientists and a lot of the practitioners, they don't feel that they have been given the possibility to be part of developing their own field methodologically, for instance. They are given the methods and given the knowledge and told what to do. But I think by giving people some philosophical tools, they could use that to join the debate, especially when it comes to these type of paradigmatic discussions within their own fields. So I like to call this the clinical revolution, where the clinicians get to say. But yeah, but that's like my approach.
Thank you. Thanks a lot.
Were there any questions in the room before I read out the comment on the Zoom? No? Okay. So this is from, so this is Elsaline's question too, but so in Mariana Barrosa's words, very interesting talk. Thank you. As a clinician and aspiring philosopher interested in EBM for a long time, I believe that EBM is often reduced to a purely empirical epistemological system, whereas in fact it has been conceived as a tripartite decision-making model where research evidence or empirical evidence is just one of three components of individual clinical decisions. The other two components are the individual patient's clinical circumstance, and the other is the patient's preferences and values. It is this model that allows individualized, patient-centered care, and this is the most widely accepted EBM model. For example, Howick defends it. I believe that this is important to acknowledge because I don't think we need to abandon EBM as originally conceived to defend a patient-centered model for clinical decisions. I would be really interested in hearing your comments about this.
Yeah, no, this is why I was talking in the beginning about the pyramid and the original EBM approach, which was very clear on the evidence hierarchy. And now that it's more blurred because you want a bit of having your cake and eat it, you want everything. And I think this kind of the three bubbles where you say, here's the evidence, here's the clinical judgment, and here is whatever the patient value is. I don't think that is a fair representation of something that is realistically possible to do in the clinic if you have, for instance, a dispositionalist bias. Because if you, first of all, the evidence is still with the hierarchy. It's not like the hierarchy doesn't exist in the evidence bubble. So even if one says that all types of evidence is interesting and relevant, some places it still says that randomized controlled trials is the strongest type of causal evidence. And when you have many randomized controlled trials, it's of course what you need. And then other type of, for instance, I mean, in nutrition science, it's really difficult to have randomized controlled trials. So some people there are talking about how we need to also allow observation studies, for instance, and other type of evidence as strong evidence of causality. So there is still this discussion. And then the question is, how big is the judgment part? Because in Norway, I think people are still quite, the clinicians, they are quite free to do what they think is right. And that's also because if something goes wrong, you have the system more behind you. It's not like you can be sued like personally. It's not that type of suing culture. I see in the UK, for instance, that it's much stricter, that if you don't follow the guidelines, you need to have extremely good reasons for doing so. And I don't know who wants to defend themselves if they make their own judgment-based decision, and it goes wrong. And then the patient preferences and patient values, to me, that doesn't bring in the patient evidence, because the patient context and the patient evidence is something that is very often ignored. So our patient advocate, Chris Price, she has lived with chronic pain for many, many years. And she says every time she used to go to get medical care, she would get exactly the same treatment because it said so in the guidelines. So even though she said to the clinician that I already tried this, it makes me worse, it makes the pain worse, she would get the same over and over and over again because that was considered best practice according to the guidelines. So of course the guidelines have changed. So today they say absolutely not do what was done to her. But still, this shows the strength of the type of evidence that still comes in the hierarchy. So that's why I wanted to say that we need to have like more critical consideration of the tensions between these bubbles, and to rethink how we think of this whole person and the uniqueness and individual variation, local context. How does that fit into this randomized control, I would say, framework that this still is? Because to me, it seems a bit like these patient preferences. To me, that sounds like you can choose if you want a pill or a shot. But that's not the type of causal information that I'm interested in. I'm interested in the room that the patient represents.
Great. Okay, so I think there's a question in here, and then we'll go to the comment on there.
That's one of our authors of the book, Matthew Lowe.
Well, thanks for your talk. I'm wondering because at some point,
that's not Matt.
Can you hear me?
Yeah.
Okay, so I'm wondering because at some point you said that this dispositions ontology explains cases of causation that didn't happen. So I'm wondering if there are any benefits of this ontology that you are arguing for, comparing to the standard mechanistic ontology and just saying that some mechanism failed at operating because there were no all entities, for example, in the mechanism, or like in general, I suppose that it's quite easy to explain causal relations that didn't happen in terms of mechanistic ontology.
Okay, so you're thinking that if it doesn't happen and you already have the mechanism, you can kind of explain it the way you want. Is that what you're thinking? I'm not sure I understood your question.
Yeah, because I think that at some point in your talk you said that dispositions allow you to explain cases of causal relations that where the effect didn't happen.
Mm-hmm.
So I suppose that the same can be explained with the standard new mechanistic philosophy or new mechanistic ontology.
Yeah, I do really like the mechanistic, the mechanism approach to causality. So that's very much in line, I would, well, for me, with the dispositions approach, because the mechanisms, the way I see it, would be to explain which type of causal factors are counteracting and, for instance, the effect and contributing to the effect. So we have written something on understanding causal or getting causal insights from failure. And there it's about if you always just get exactly the outcome that you expect, you will learn that there is a correlation between A and B, but it's not so easy to learn about the complexity of the mechanism. But when you get a different outcome from what you expected, then you can start to study the context and see what is different here from what is normally the context. So this is something that can happen with side effects, for instance, that maybe someone gets a very rare side effect from a drug. Maybe it turns out that 1 or 2 people only in the whole world has gotten this side effect, but they both suffer from some weak liver or liver failure. And maybe then one can learn something about the mechanism of the drug, that it, for instance, metabolizes via the liver, blah, blah, blah. So, I mean, sometimes it's useful to look at different parts of the context that maybe you didn't have focus on from before, and that could give you maybe a better understanding of what type of patients would benefit from this medication and what patients might be harmed from it, so that instead of just talking about numbers needed to treat, numbers needed to harm, you can learn more, I mean, from maybe more about the subpopulations, if that's what your aim is, and say, okay, this drug should be avoided for these and those groups. So that was what I was trying to say. But when it comes to the dispositions, it's not easy to show that you actually have a disposition. It's not the type of causal knowledge that is ever complete or ever conclusive. It's more indications. So it's not like you can just claim dispositions whenever based on some theory. I don't know if that worked.
Great. Okay. I think Elseline has a final question. There's also a final comment, which I'll read out very quickly. Firstly, Matthew Lowe, who said, as part of writing the book, just made a comment that research evidence does not talk for itself and is value-based. This speaks to the philosophical bias that Rani has been speaking to. And then Mariana, in response, wrote, thank you, I missed the first 5 minutes talk. Agree, and this is complicated because EBM is not what guidelines say. And as your book well acknowledges, guidelines are very problematic in many ways. So Elseline, did you want to ask one last question or make one last comment?
Yeah, if it's allowed, I have a question. Thank you, Rani. So I always wonder with, I mean, a talk like yours, but in general, right, when people put pressure on evidence-based medicine, I think legitimately evidence-based medicine as it is practiced are laid out in guidelines for being insufficiently attentive to many of these patient-specific aspects. Whether, and then, you know, an alternative is on the table, like in your case, the dispositions approach, which like you just explained, right? One of the things it might make us look closer at particular kinds of patients and features they have that interact with things we might do to them. to what degree is this really something about evidence-based medicine versus other approaches? And to what degree is this about the kind of things we're willing to look for when we do and do not stratify patients into groups, right? So here's an example of an area I happen to know a lot about. In the context of childbirth and pregnancy, there's lots and lots of research, really fine-grained risk calculations, looking for the influence of blood pressure and body fat percentage and places where you give birth, and all sorts of characteristics that are tied to outcome measures. How long a pregnancy takes, whether you should cut it off early, what happens if you induce, et cetera, et cetera. And then there are other domains that might be relevant to people's outcomes. Say family history of, how pregnancies in your family went, you might think are relevant. Or when it comes to pregnancy duration, maybe it's worthwhile investigating what the pregnancy durations of other people in the family was. And nobody's interested in looking at those. And one way you could go is you say, there's something wrong with our stratification and we don't pay sufficient attention to the kind of personal characteristics of people. And so we need to have a different kind of account. But another way of looking at it would be, well, why are we kind of willing to take, weight or blood pressure or length of pregnancy as determined by the clinicians as potentially relevant factors for making different guidelines, different recommendations, but a whole bunch of other factors, right? Such as, like in the example you gave, people self-report on how they responded to a particular drug, which we're kind of not willing to take as relevant factors for stratifying patients into groups. Because as you know, any kind of evidence search is always going to have to make stratifications, right? It's going to have to group people and it's going to have to split people. Why go for something like dispositions rather than kind of honing in on what sort of factors might be appropriate splitters and groupers?
Well, I would say the splitters and groupers are the relevant dispositional properties. That is part of the mechanism. So if it's social, it could be social mechanisms. We have, Anna-Louise Kirkengen, who wrote the last chapter of the book, she's been a GP for years and years, her whole career, and she's been really struggling to get the medical community to accept how chronic illness can be caused by childhood trauma. And very often people are looked at from certain, blood pressure, blah, 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 given various diagnoses, different treatments. But then the clinician who meets them and hear their story, they would maybe want to target this completely differently. So now she's listened to because a lot of the biochemical research on allostatic load is backing up what they have seen, in the clinic. But a lot of people are mistreated in the system because they are treated as fragments of their different body parts with different diagnoses attached to them and different types of treatment. So it's actually quite reductionist and fragmented, the way that the scientific evidence in medicine is generated. And so this type of comorbidity, multimorbidity, and what are the underlying causal story leading up to these issues, they are very often not targeted. And I don't know how it is in UK now, but in Norway, I think the normal time to have with the clinician is like 10 minutes. And in that time, they're supposed to find out what's wrong with you and give you like something you can take home with treatment. So, so these people who I work with, they all criticize this type of framework with where the time and resources spent on the individual is thought in a very narrow, short-term image and not during their lifetime. So sometimes she talks to patients who have been in the system for years and years and gotten worse and worse, and no one ever asked them what happened to them when they first got ill. And she says, so that actually the system has spent millions and millions and hours, and it doesn't take that long to to kind of meet the patient and learn more about the context and their history. So I think a lot of the clinicians are frustrated that they actually see they have a lot of the knowledge or a lot of the understanding, but they're not allowed to use it without within the system. So that's frustrating. But I would always say it comes back to the dispositions within my philosophical bias.
Okay, good note to end on, I think. So thank you so much, Rani.
Thank you. And thank you for the questions and feedback. They were not easy.
And we'll meet back in about 20, 25 minutes for Source Talk.